The addition of real numbers. Recall there are many real numbers. It's easy, if you remember, to add whole numbers. What are whole numbers? Positive integers and 0 are whole numbers. So to add whole numbers, we can do this quite simply. 5 plus 2 we all know is 7, not a problem. Positive rational numbers aren't difficult either, especially if they're in decimal form, something like 1.21. These are real numbers. These are also rational numbers. I know they're rational because the decimal terminates, it stops, it doesn't keep repeating, and they're easy to add as long as I remember to line up the decimal. So if I line up the decimal here and here, 0, 1, 2, 5, then it's easy to add these 5, because there's a 0 here, right? 3 and 3 and 1. If these were in fraction form, if I had something like 1/2 plus 1/6, well, certainly these are not what's above, but certainly these are also easy to add. We just have to have a common denominator. I'd multiply this first fraction, this 1/2, by 3 over 3 and get 3 over 6 plus 1 over 6 is equal to 4 over 6, which is equal to 2/3. Alright, so adding positive numbers makes sense and is fairly easy to do. We can look at these in a similar fashion by drawing a number line. If I take a number line, say a 0 here, this is the real number line, so it goes on forever in the positive direction and on forever in the negative direction. So these are my negative numbers on this side of the 0, and over here the positive numbers, and that's always true on a real number line. Let's add 5 and 2 this time. If I take 5, 1, 2, 3, 4, 5 on the number line, and I'm going to add 2, it would be the same as moving 2 places to the right. 5, I'll add 2, and I land at 7. So this is 2. So on the number line I can say that 5 plus 2 is equal to 7. To add integers, I now have numbers that are negative. So I could add something like 5 plus a negative 2. How do we do that? Well, we can use the number line. We can say, alright, give myself a straight line if possible. I'll move the 0 over a little bit. There's my number line, and I'll start again at 5. So I'm going to start with this 5, and I'll draw it here. 1, 2, 3, 4, 5. And now I'm going to add a negative 2. This negative 2 shows up by moving the other direction. 1, 2. We go to the left. So we end up at 3. So that's where we end up. So 5 plus a negative 2 is equal to 3. If I start out with 5 cats and I give 2 away, right, then I end up with 3 cats. Let's take a look at this with some simple examples. a and b are real numbers, so I'll have a plus b, where a and b, and I'm going to use a symbol here, means are elements of, or they belong to, the real numbers that I'm just going to abbreviate as a capital bold R. So these are real numbers and we're going to add them. I'm going to use integers in this case just for simplicity. 2 plus 3. Well, of course it's 5, and we can look at that on a number line. Right? We can say, well, if I'm at 2 and I add 3, 1, 2, 3, then I'm at 5, because we're just counting. Now if I have 2 and I add a negative 3, again, I'm going to now go to the left. So I start with the first number. So here's 2. Different number line, right? And I'm going to go to the left. 1, 2, 3. Oh, sorry. There we go. 1, 2, 3. So if I was at 2, this would be, going to the left would be a 1. My 0 would be here, and right now I'd be at negative 1 on the number line. So this is equal to negative 1. 2 minus 3 is equal to negative 1. If I have minus 2 plus 3, let's see where that ends us up. Now I'm going to start at negative 2. I'm going to add 3. 1, 2, 3. So I'm at negative 2, negative 1, 0, 1. So I end up 1, 2, 3, because I'm adding 3, so I go to the right, and I end up at 1. If I have two negative numbers, minus 2 and minus 3, I'm going to add two negative numbers. Make a number line. Start at negative 2. I know I'm going to go to the left because of this negative. So 1, 2, 3. I go to the left 3 places. So I'm at negative 2. If I'm going left, this would be negative 3, negative 4, negative 5. So I end up at negative 5. So in a plus b, if b is positive, written b is greater than 0, then we move to the right. If b is less than 0, in other words b is negative, we move to the left. What happens if b equals 0? How far are we moving? Well, if b equals 0, if I take any number, and I add 0 to it, I'm just going to get a back, right? Because we haven't moved at all. Now, often I don't use a number line. I just add signed numbers. So if I take 2.0 and I add a negative 0.5, I know that 0.5, I ignore the negative, and I know that 0.5 is less than 2. Right? It's a smaller number, 2 or 1/2. So this negative number and this 2, because one is negative and one is positive, I'm essentially subtracting. So if I take 2 and I subtract a half, I end up with 1.5. And then I look at the signs. I say, well, I've got two opposite signs. I subtract the two numbers, and I give the resulting number the sign of the biggest one, in this case 2. So that's how I add signed numbers. If I have, say, minus 5 plus 3, I'm adding a negative 5 and a positive 3. I can certainly put this on a number line, or I can say, well, I've got one is positive, one is negative, So I'm going to subtract the two numbers, 5 and 3, and I get 2. Then I go back and I look at the sign and I say which number is bigger. Bigger in terms of its, what we say, absolute value, right? The absolute value of a negative 5 is 5. The absolute value of 3 is 3. So sort of in my head I'm saying the 5 is bigger than the 3, so I'm going to take that sign, so this will be a negative 2. All right. If the signs are the same, if I have, say, minus 2 plus, I'm going to use parentheses just to make it a little clearer. If I have minus 2 minus 1.5, now the signs are the same, so I'm just going to add the absolute values. I'm just going to add the 2 and the 1.5, and I get 3.5. And then I just give it the sign that they both have. They're both negative, so that will also be negative. And you can go back and try each one of these using a number line, and you'll see that it works just fine. Okay, the last thing I want to cover in this section is to simplify an expression. So here's an expression. It has 4 terms. It has 2 variables, y and t. An expression is something that does not have an equal sign, remember. It's composed of variables, numbers, and operators. In this case, my operator, this is the operation, addition. These negatives inside the parentheses are a signed number. They're not subtraction. All right, it's a negative 9 that's sitting here. So I'm going to add these numbers by combining like terms. That's how we simplify expressions, remember. They don't have an equal sign, so I'm not going to add one. I'm going to group the y's together, 5y plus a negative 9y. Then I'll group the t's, so plus, just moving things around. I can do that because they commute, right? And now I've got 5y and a negative 9y, so I'm going to, they're different signs, so I'm going to subtract them and I get 4y. And then I look for the sign and I say, well, 9 is larger than 5, so this is going to be a negative. It'll take on the sign of the larger number. And over here I have minus 10t and a plus 15t. Again, 15 and negative 10 have different signs, so I'm going to subtract these two and I get 5t. And I look again and I say, alright, I've subtracted 15 and 10, I get 5. Which one, 15 or 10, is larger? 15 is larger, so I take the plus. And this is my simplified version of the expression.